All right, check it out. Right up. Nope. Nope. Yep. There. Look at that. We are measuring distance, right? We got stereoscopic vision. Actually, they call it binocular vision, right? So we're using this binocular vision and we're figuring out how far away things are. Do you believe that that's 10 inches away? It is. Do you believe that's 20 inches away? Yeah, it is. Okay, so let me show you what's going on with this crazy thing. All right, no mechanics in this. Just this is all about cameras, right? Okay. All right, before we get started, let's dispense with a little math. Now what we're trying to do is use two cameras. So let's say we've got a camera there and a camera there. And we're trying to use that to locate a point out in space, right? So we can assume that these cameras are on the same plane, and we know the distance between these two cameras, okay? So if we take camera A and we find the angle to that point, and then if we take camera B, we find the angle to that point, then we can use a wonderful math thing, trigonometry thing called triangulation to figure out where this point is. Okay, it was used in the old days. You know, they would use it on a coastline, and they would observe a ship from two positions, and they could figure out where the ship was, or they could use it for mapping. They use it a lot in surveying. So if you have two positions, you know how far apart they are, then you can map other positions by calculating, using these angles. Okay, so it's just a little trigonometry thing. So we've got to make ourselves a right triangle, right? So this is a right triangle, both two right triangles. Okay, and we know the distance between these 2 points, which is the distance between our cameras. All right, well, if you remember, so a little bit of trigonometry back in the day, right, then you know that tangent is equal to the opposite over the adjacent. Okay, so for this angle A, and here's an angle B, so this is A, then the opposite, which is this one, and this is the adjacent. For B, this is the opposite side, and this is the adjacent. Okay, so basically what we know, that if we know this distance between our cameras, they call it L usually. So if we know this distance L between the cameras, then we know that it's this adjacent plus this adjacent. Okay, so we can use this tangent formula to figure it out, and figure out this thing right here, D, right, which is the distance away from this line. Okay, so basically what we just have to set up is that L, this distance here, is D, so we're using this formula, we're just readjusting it, D over tangent of angle A plus D over tangent of angle B. Okay, so we can take these two things and plug in what we know, which is L, A, and B. We got these, A and B. We know these angles, we can get their tangent, and we plug it all in and we solve for D, which gives us this distance. Okay, and then we can calculate all this stuff. So everything can be calculated. So that's what we're doing, triangulation. The critical thing we've got to have then is an angle from camera A and an angle from camera, my pen's giving out, angle from camera B. All right, so that's the real critical thing to this formula. So how are we going to do that? Well, let's just, when we look at our camera on the computer, we get a frame, right? Okay, and we know, well, I'm just going to do this in the x-axis. So first you have to do it in the x-axis, and then you use your triangulation in the x-axis to figure out your stuff, and then you do it in the y-axis and use your triangulation there to figure out. So let's just do it in the x-axis. All right, so we know that our frame, in my case, 640 pixels wide, right? Okay, so here's our camera down here, and our camera has a field of vision. This is what it can see. All right, in my case, I know that my camera, we'll talk about this later, my camera has a field of vision of 78 degrees. All right, so let's just do a little more trigonometry. Let's divide this in half. There's a 0 point, and then let's just say we'll divide this. So now we have right triangles, right? Just like that, just like we were kind of doing before. All right, so we know this is 640, so half of this is 320. Okay, we don't know what this is, but we do know that this is going to be 39, right? 39 degrees right there. Okay, well, we have an angle, we have the opposite, we have the adjacent. So, you know, again, we remember that tangent equals the opposite over the adjacent, right? So we know then, based on this, that that the tangent of 39 equals 320 pixels over something x, which is the adjacent, right? And then we just swap that stuff around over tangent 39. That's about 0.8, and you do the division, and what we end up with is x. Oh, well, that should be d, right? Because we're calling it d. Okay, so d is somewhere around, well, this is an approximation, about 395. Okay, so 395. So that's 395 units. It's really pixels, right? Because this is a theoretical distance from the camera to the frame that we see. So now that we know this theoretical distance from the camera to the frame that we see, whatever pixel distance we have across here, so, you know, whatever it is, so, you know, the point is here, whatever pixel distance this is, we can use that as the opposite, and we can use this as the adjacent, and then we can take the tangent, or well, I mean the arc tangent of it, because we're going backwards, right? So we take the arc tangent of it, and it will give us an angle. Okay, so that's what we're doing. Overall, we're using triangulation from 2 points, our cameras. We're triangulating, we're finding points out in space so that we know exactly where they are in 3 dimensions. And then for each camera, this is how we're basically figuring out, when we look at a frame and we pick a point, we can know how many pixels out it is, right? And then we use that distance and this theoretical distance, and we can figure out the angle from center. Of course, then we can also do it across this way, right? And we can use the angle, the sort of the y-axis, and we can figure out how far it is from this center line. Okay, so we can get our x and y, our x this way, y this way, and then z is going to be the actual distance. That's really z, right? The actual distance away from the cameras. So that's what we're doing. So the next step is figuring out what your camera field of view is, both in the X and the Y, so that we can make this calculation, so that we can make this calculation. All right? All right, I'm using these little Ubisoft, these were motion capture cameras that came with a game, I don't know, a long time ago. Anyway, you can get these, I got these for like $4, $4.50 or something like that on eBay. Got a couple of them. We'll see the other ones later. All right, they're supposed to have a width of viewing, you know, sort of on the x-axis like that of 78 degrees, and then on the y-axis, I think it's around 63 degrees. You don't get that in the specs. You kind of got to figure it out yourself. But the way that I did it is basically I took this piece of paper and I drew a center line on it, and then I've gone ahead and drawn these on here, but I'm going to show you in just a minute. But basically I just put the camera down here, lined it up with the center line. I put some crosshairs on it. I'll show you that in just a second. Lined it up with a line, and then I got everything lined up, and then I just went as far as I could see on the edge of the camera, edge of the frame, on the computer, edge of the frame, and then I made a mark. And then I went over here on this side, same thing, far as I could see, I made a mark. Then I turned the camera, so I did it this way, and then I turned the camera this way and did it again to get the y-axis. So I lined it up, made a mark, just as far out as I could see. And then you just get yourself a protractor and measure your angle, and then for sure, even if the specs that the manufacturer gives you are not quite right, you'll know for sure that your camera, or what your camera's angle of view is. This is the view from the camera. So I've got my angles right here. I'm putting the camera up against the edge of the table. I'm going to raise it up. And then you see when I adjust it to the center line, it is not easy to do. Alright, so that's about adjusted, but you see what you get if you put the marks. So if you went out and said, okay, that's as far as I can go right there, and that's as far as I can go about right there, and you can put your marks, and then you'd be able to measure it, okay? And then turn your camera the other way. This is getting confusing. Oh, wait a minute. And then, but the same thing, that you gotta line it up on the center line. Vertical. Thing lined up. And then, I'm not making this look very easy, am I? Yeah, anyway, you catch my drift, right? So now we're doing it on the y-axis, and then we can say, I can see all the way to here, and all the way over to about here. You make your marks, okay? And then once you've got your marks made, and then you just get your protractor and line it up, measure it out. That's all you got to do. Alright, this crazy looking beast is again a couple of these Ubisoft cameras here, and I've got this piece of PVC pipe with these are tubes from connectors. Now eventually I'll clean this up and paint it, right? Paint it green like the rest of the targeting stuff. But this is just what I'm using to experiment and get this stuff done. All right, so it's just a clamp, just pulling these ends in, clamping on the camera, and this is holding my cameras in the right position, because it's really critical that you get these cameras lined up so that they're looking exactly parallel to each other. Okay, so you've got, actually let me get another pen. All right, because you've got to, it's kind of critical. So you gotta, these are, viewing this way. You can't have them doing this, right? You want them looking straight out, okay? And you can't have them doing this, right? You want them right parallel together. And then also, they got to be straight up. They can't be twisted like this, right? So you've got 3 axes that you've got to adjust these cameras with. And so that's what's going on here. These tubes are just kind of clamping in on there. So if I loosen this up, then I can adjust these things around. So I got one of them pretty straight the way I wanted it, and then I worked on the other one and got it all lined up. I'll show you that in just a second. And then I've got these marked, right? So here's your, well, let's see. Yeah, that going that way. So here's your left camera, and here's your right. So in all this stuff, the left camera is the boss, right? It's the #1 camera. All right, so that's what I'm working with here. And let me show you how I got it lined up. This is how I did the alignment. I took, I got my cameras, and then I took the 2 frames and just sort of lined them up next to each other. And then put this ruler here because I knew it's horizontal, right? Like the desk, you can also use this line on this shelf. This ruler here, okay? And then I worked with them until I got everything lined up. So what you're working on is that this line is horizontal. Same with this one, horizontal. And that when you line it up on some, you know, if you gotta have this straight with your cameras, with your camera bar. But so you get this lined up with your camera bar, and then you want to use that to gauge whether your cameras, whether this camera is too high or too low. So even though it does say it doesn't quite join up right there, that's just differences in the cameras themselves, right? And then, but you want this line to be all the way across, right? So that this takes care of 2 axes, okay? So make sure they're aligned up and down, and then it makes sure that they're aligned horizontally, okay? And then to make sure that they're not cross-eyed, I started with this ruler, okay? And I put it up here, and I put one at 0, and I said, okay, it's almost at 6. That's the 6-inch mark. So set that to 0 for the left, and then the right one is at 5 and 15/16. All right. So the idea, though, is that if these things are aligned, then up close, it's 5 and 15/16 apart, and then when you move away, it should still be 5 and 15/16 apart. Can't see that very well, though. So I made this. I drew this piece of paper. Right. So here's our 2 lines. They line up close, and they line up. Now look, we're looking. Okay, so we're looking at this line for the left camera and this line for the right camera. So if you're, of course, this is not going to line up and that's not going to line up, okay? But that's the idea, that you want to get it lined up so that your lines are lined up at a distance and also they line up close, okay? Now it looks like this is a tiny bit out of alignment, but it's good enough to make this video. Okay, so now our camera, well, our cameras are all set up. All right, there we go. Okay, now we got this thing running. Now what we're looking at is we now have X, Y, Z, and distance from 0. So this is actually coming from the center of the camera, which you cannot see, right? This would be the center of the right camera. This would be the center of the left camera. But this is coming from somewhere in between. So that's what we're working off. So these dimensions are coming off of there, right? Okay. So you got X, Y, and Z. So you know, X and Y is self-explanatory, and Z would then be the distance out, and then D is the actual distance. So Z is measured straight out, whereas it might actually be an angle out. So the D is the a squared plus b squared, or x squared plus y squared plus z squared, and the square root of that, right? And that gives us what the D actually is. Okay, so now we got this thing running. All right, so all this stuff working together. So you can see that we're targeting. Okay, so you can see we're targeting in both frames, and then the location of the target in both frames, we're getting the angles off of that, and we're using our triangulation, and we're coming up with distances. Okay, so this ruler is at 30 inches, right? So right about here is 30 inches. We're getting 30, 28, 20, you know, so let me get a good solid movement here. Yeah, so it's about right. It's pretty close. I mean, even though our cameras are a little off and we didn't do all the fancy camera calibration and taking out all the you know, distortion that you find in the camera, we're still getting that. So let's see if I get all the way back here. What is it? Let me see what it says. Let me get a good target. All right, so too much movement. All right, here we go. Getting the target right in here. It says about 42. So there it is, right there. Okay. So now, of course, you're most accurate. There's going to be a range where you're most accurate. So this is still pretty good right in here, though. And then as you go out to the extremes, you're going to lose your accuracy. Okay. I can't even get this thing targeted. I've kind of got the targeting dumbed down a little bit. All right. So anyway, it's working okay. That's what we got, is the target. Big hands. Big hands. Okay. Anyway, so that's where we are. And I guess we'll hook this thing up to the machine sometime. I got so many other projects I want to work on. Anyway. Oh, look down here. Can you see this right down here? Look at this. For some reason these cameras are giving me this error. Just these cameras. Other cameras, it doesn't give me this. I don't know what. It's just these old cameras, I guess. What am I doing? Let's get these cameras back up there. Yeah. All right. So there we go. That is. Let's see where it targets on me. Oh, it's targeting that logo, because the red around it doesn't show as movement. Let's do it.